Right. So, good morning, everyone. I am Dr. Janish Patel. Uh, I am going to teach you this module, which is called magnetostatics. So, as the name indicates, it is basically the science of the magnets. Okay, magnetic field. You might have all been familiar with the magnets in your childhood days. You might have played with it. Magnets, bar magnets, small tiny bar magnets. So, now today we will see how this magnet actually works and what are these scientific principles associated with them. So, here I have shown this atomic structure of a single elemental material. So, we want to see what is the origin of the magnet. Okay. So, for example, as we see over here in the slide, this atomic structure of a given material, if I pick up a tiny atom, so inside the atom there is a nucleus in the center and there are electrons which are revolving as it's shown in this animation. So, as this electron moves, so whenever a charge moves like this in a circular fashion around the nucleus, it creates a uh, pole. It creates a pole, basically what we call it as a south pole and now north pole. Like generally what we see in the magnets, there are two poles, south poles and north poles. So, each electron revolving around a nucleus, it behaves like a magnet. So, all these atoms are actually nothing but like they are tiny bar magnets. So, if you observe it from one side, it would behave as a north pole of a magnet, and on the opposite side of that atom, it will behave as a south pole. So, now north pole and south pole, the two opposite poles. So, in a given material, these magnetic atomic crystals would form the domain of the magnetic fields, and all these domain of magnetic fields, they would align in particular directions. Okay. And when this magnetic material is in contact with a magnet, so this magnet will be aligned in this magnetic field, and based on those magnetic interactions we form different categories of the magnetic materials. Okay. So, we will not go in that detail, but I would just focus on this magnet structure. So, as we have mentioned, the magnets has two poles, south pole and the north pole. So, all the magnets opposite poles, so they would attract with each other. So, as we see over here, south pole will attract to the north pole of the opposite other magnet, and the north pole of the same magnet would attract towards the south pole of the other magnets. And this polarity would actually cause the magnetic materials to stick the magnets, the south pole and the north poles. So, opposite pole would attract and the like poles would actually repel. So, south pole would actually repel, they would and north pole would actually repel. Now, this is all about the basic information about the magnetism, origin of the magnetism in the material. Now, let us see the history of this magnetism. So, history of this magnetism begins from the ancient times known as Magnesia, which is in the ancient Greece. So, according to the legend, the shepherd noticed that the nails of his shoes and the metal tip of his staff were stuck to the black rock. Okay, so, it is the name given to the people who climb the mountains or those who walk on the rocks. Okay. So, they when they were walking on the rocks, they noticed their nails of their shoes and the metal tip of the staff, they would actually stuck to the black rock. They are standing on that particular rock. So, that was the that is how slowly this thing started become very mysterious. And if you look at the reason, what is the reason for that attraction? So, for a long time magnets were thought to be somehow magical and were treated as a novelty. And so, the rock had a magnetite in it. Actual reason is that the rock had a magnetite in it and naturally occurring iron ore which has a magnetic properties. So, this magnetite is actually naturally occurring magnet which has a magnetic properties. So, whenever the shepherd would pass by whenever he would stand on the rock, and the shoes was actually having some metal tips. So, those metal tips would actually attract with this magnetite material. So, this attracted the iron nails to his shoes. Now, this was discovered, it was discovered that a tiny silver of this magnetic rock, if you take the rock and you take the tiny silver piece of that rock, and if you put it on the water surface, it would actually float. Okay, it would float, such as shown in over here in this animation, and this will spin on its own until one end of the magnet would point towards the north of the earth direction. So, the same pole will always ended up pointing towards the north. Okay. So, one pole of that rock would actually always point towards the north. So, it was very magical in those days. So, the pole which point towards the north is what is known as the north pole, and the other pole that point towards the south is what is known as the south pole. And all these magnets would have north and south poles, no matter whatever their shape is. Okay. And even if you try to break a magnet, if you break a magnet into two pieces, then also in those two pieces you will have two poles, north pole and south pole. So, if you pick up a bar magnet, let us say you cut it down into two pieces. So, both the pieces would have their own south north pole in both the magnets. If you further break it down, you will have 4 magnets, and all of those 4 magnets will have their own south and north poles. So, magnetic field is actually strongest at the poles. If you go at the center of that pole, the strength of the magnetic field is highest at that point. The first known magnets were naturally occurring lodestones, which are of the iron ore, which we call it magnetite, which has a chemical formula Fe3O4. So, these are the naturally occurring magnets. The people of ancient Greece and China discovered that the lodestone would always align itself in a longitudinal direction if it was allowed to rotate freely. It is almost like the previous example, when you take the piece of that rock and put it on the surface of the water, it would align itself to the north pole of the magnet. So, this property allowed for the creation of the compass, which we call magnetic compass. So, 2000 years ago this was found, and this was the first known use of the magnet, the application of the magnet to find the directions while you are traveling on the earth. In 1263, Pierre de Maricourt, he was a French crusader. So, he mapped the magnetic field of the lodestone with a compass, and he created the very first known magnetic compass. So, he was the first who created the magnetic compass, and with this magnetic compass, people would travel in ships by taking the directions. They would travel to the different part of the world, to north, south, east and west. So, he discovered that magnet has two poles, north pole and the south pole. In 1600s, William Gilbert, a physician of Queen Elizabeth I, he concluded that Earth itself is also a giant magnet. Earth itself is a giant magnet, and he also wrote a book which is called The Magnet on this subject. You can find a copy and you can read it. It is very interesting. He was the first person who said that Earth itself is a magnet, and if we see the geomagnetic field today, so this is how it looks like. The north pole and south pole of the earth, as it continuously rotates, the magnetic field lines, as you see in this animation, these magnetic field lines, they emanate from the north pole and they ends in the south pole, outside the earth. In 1820, a Danish school teacher, Hans Christian Ørsted, so he discovered that an electric current flowing through a conducting wire can also cause the compass needle to deflect. So, this was another interesting observation made by this school teacher. So, when you pass an electric current when you pass an electric current through a conducting wire. And if you put a magnetic needle, you see over here, you have this battery and you have a wire connected to this, and this is a tapping key. So, the moment you press the tapping key, current would flow through the wire, and this magnetic needle would actually cause the deflection. So, this deflection would indicate that magnetism and electricity, they are not independent of each other, they are very well connected, they were very well connected. And we see that how this magnetic field appears. So, magnetic field due to the bar magnet, which is shown over here in this figure. So, magnetic field due to the bar magnet is something like the south pole, as we have just seen the south pole. From here, the magnetic field enters inside the magnet, and from the north pole it emanates. From the north pole, the magnetic field line emanates and it enters towards the south pole. So, if you put small tiny needles in nearby places to this bar magnet, so this needle would be aligned in this way, okay, and the magnetic field lines would actually float something like that. They would actually create an picture something like this. They emanate from the north pole and enters in the south pole. Now, if you want to understand how the mechanism of this magnetic field works, depending on the orientation or the passing of the current through the conductor. So, there are certain experiments that one can perform. For example, over here we have a battery through which you are passing a current and through the conductor, and as you pass the current through the conductor, you would see over here there are some iron cores, they are placed over here. So, they will all would align in this circular fashion, and this is nothing but it indicates these lines of magnetic force. It indicates the lines of magnetic force, or you can call it as magnetic field lines. So, as you pass the current, the magnetic field lines would be like circularly created to around this wire of the conductor. And if you want to identify what is the direction of these field lines, okay, that you are passing through the current that you are passing through the conductor, so that is given by the right hand thumb rule as shown in this figure. So, if you imagine that you have a conductor which is actually put vertically like this, and you are passing a current in this direction. So, you put the thumb in the direction of the current, and if you see all the fingers, so these fingers would actually indicate the direction of the magnetic field. So, as the current is passing through this conductor, the magnetic field lines are actually created circularly, they are like this around the conductor of the lines which are passing through this conducting field. Okay. So, this is what is known as the right hand thumb rule. So, the field lines are created circularly like this, field lines are created circularly like this, and these are understood by the right hand thumb rule. These are understood by the right hand thumb rule, and there are many applications of this magnetic interactions with the magnetic force. As you pass the current through the coils, it generates a magnetic field. Okay. So, thank you very much. This is it all for today. We would have some more interesting topics coming up. How would you utilize this creation of magnetic field due to the current, how it works, and how we can use it for application purpose. There are applications like the generators, electric generators, or the electric motors, like even if you see if you have a fan in your house, then if you would open the fan inside, and you would see there will be very large coils which are placed inside, and the current when passed through that coil, it would generate the magnetic field, and that magnetic field would cause the fan to rotate. Okay. So, that we'll discuss in detail, but first let us revise whatever we have learned so far. So, you go through this presentation. I will share this PPT with you, and there are also the books available. You can refer the book of Fundamentals of Physics by Halliday, Resnick and Walker. Okay, Fundamentals of Physics by Halliday, Resnick, Walker. There are various editions. We are using the 5th edition, and in the 5th edition you will find this chapter where you would see the magnetostatics chapter is specifically uh, devoted for the understanding of the magnetic field. Okay, so that's all for today. Thank you very much. We shall meet in the next class and we'll discuss more in detail. So thank you very much.